Our home is the Milky Way galaxy. This vast collection of stars, planets, and cosmic dust is where we reside in the universe. It's a vast and beautiful place, stretching across the night sky like a celestial river of light. The Milky Way is filled with stars, gas, and dust, creating a complex and dynamic environment. It's a spiral galaxy, shaped like a giant pinwheel, with arms that twist and turn around a central bulge. We live in one of the spiral arms, far from the center in a region known as the Orion Arm. When we look up at the night sky, we are seeing our own galaxy, a glimpse into the vastness of our cosmic neighborhood. We see a band of light stretching across the sky, a dense collection of stars that form the Milky Way's disk. This band is made up of billions of stars, each one a sun in its own right, with its own system of planets. The Milky Way is so big it's hard to imagine, a colossal structure that spans an incredible distance. Our galaxy is about 100,000 light-years across, a measurement that boggles the mind. It takes light 100,000 years to travel from one side to the other, a journey that defies our everyday experience of time. That's a very long time. Imagine the countless events that have occurred in that span. Our sun is just one of billions of stars in the Milky Way, a single point of light among a sea of others. There are many different types of stars in our galaxy, each with unique characteristics and life cycles. Some stars are much bigger and hotter than our sun, burning brightly and living shorter, more intense lives. Other stars are smaller and cooler, like red dwarfs, which burn their fuel slowly and can live for billions of years. The diversity of stars in the Milky Way is truly astounding, each one contributing to the rich tapestry of our galaxy. The Milky Way gets its name from its appearance. Imagine spilling a glass of milk on a dark night. You would see a faint white streak across the darkness. To the ancient Greeks, this is what our galaxy looked like. They called it the Milky Circle. Today we know it's a galaxy, a massive collection of stars, gas, and dust bound together by gravity. But why is it shaped like milk spilled across the sky? The Milky Way is a spiral galaxy. Spiral galaxies have a central bulge and spiral arms that extend outwards. Imagine a frisbee spinning in space. That's kind of like the shape of the Milky Way. Our solar system sits in one of those spiral arms. We are located about 2/3 of the way out from the center. The spiral arms of the Milky Way are not solid structures, they are areas of higher density within the galaxy's disk. Imagine a traffic jam in space. That's kind of what the spiral arms are like. They are areas where stars, gas, and dust are more concentrated. These arms are where new stars are born. The gas and dust in the spiral arms provide the raw materials for star formation. Our solar system, including our sun and Earth, is on a journey. We are orbiting around the center of the Milky Way. It takes us about 230 million years to complete one orbit. That's a very long trip. As we travel through space, we encounter different regions of the Milky Way. We pass through areas with more stars and areas with less stars. At the center of the Milky Way lies a mysterious region. It's a place of intense energy and powerful forces. This is the galactic center, a place we cannot see directly with our eyes. Dust and gas obscure our view, but radio telescopes and infrared telescopes allow us to peer into this enigmatic realm. What lies at the very heart of the Milky Way? Astronomers believe a supermassive black hole resides there. This black hole is called Sagittarius A*. It's a region of space-time where gravity is so strong that nothing, not even light, can escape. We know it's there because we can observe its effects on nearby stars. These stars orbit the galactic center at incredible speeds, their paths dictated by the immense gravity of the unseen object. Section 5. Stellar nurseries, where stars are born. Stars are born in giant clouds of gas and dust. These clouds are called nebulae. Nebulae are some of the most beautiful objects in space. They come in a variety of shapes and colors. Imagine a giant cloud of cosmic smoke. That's what a nebula is like. But this smoke is not like the smoke on Earth. It's made up of hydrogen, helium, and other elements. These clouds can be vast, stretching for light years across. Within these clouds, gravity pulls the gas and dust together. As more material clumps together, the cloud's core gets denser and hotter. Eventually, the temperature and pressure at the center become so great that nuclear fusion begins. A star is born. Section 6. The life cycle of stars, from birth to afterlife. Stars like us have a life cycle. They are born, they live, and they die. But a star's life cycle is much longer than ours. It takes millions, billions, or even trillions of years for a star to complete its life cycle. A star's life cycle is determined by its mass. Massive stars live fast and die young. They burn through their fuel quickly and explode as supernovae. Less massive stars live much longer lives. They slowly fade away, becoming white dwarfs. When a star runs out of fuel, it can no longer support itself against gravity. The core of the star collapses, and the outer layers are ejected into space. This is called a supernova. Supernovae are some of the most energetic events in the universe. They can outshine entire galaxies for a short time. Section 7. The dazzling variety of stars. Not all stars are created equal. Each star is unique, with its own set of characteristics that make it stand out in the vast expanse of the universe. They come in a variety of sizes, colors, and temperatures. This diversity is what makes the night sky so fascinating to observe. Some stars are small and faint, barely visible to the naked eye, while others are massive and bright, dominating the night sky with their brilliance. Some stars are red while others are blue. The color of a star is determined by its surface temperature, with red stars being cooler and blue stars being hotter. And some stars are very hot while others are relatively cool. This temperature difference affects not only their color but also their lifespan and the type of light they emit. Our Sun is a yellow dwarf star. It's a fairly average star in terms of size and temperature, but it plays a crucial role in our solar system. It's very important to us because it provides the light and heat that we need to survive. Without the Sun, life on Earth would not be possible. The color of a star tells us its temperature. By studying the color of a star, astronomers can determine how hot or cool it is. Blue stars are the hottest stars, with surface temperatures reaching up to 40,000 degrees Celsius, while red stars are the coolest, with temperatures around 3,000 degrees Celsius. Our Sun is a yellow star, which means it's somewhere in between. Its surface temperature is about 5,500 degrees Celsius. The size of a star is also important. It can influence the star's brightness, lifespan, and the type of elements it produces. Giant stars are much larger than our Sun. These colossal stars can be hundreds of times larger in diameter and thousands of times more luminous. They can be hundreds of times larger. Such stars often have shorter lifespans because they burn through their nuclear fuel much more quickly. Dwarf stars are much smaller than our Sun. Despite their size, they can be incredibly dense and have long lifespans. They can be as small as the planet Jupiter. These stars burn their fuel slowly, allowing them to shine for billions of years. Section 8. Stellar graveyards, white dwarfs, neutron stars, and black holes. These are the remnants of stars that have reached the end of their life cycles. When stars die, they leave behind remnants. The nature of these remnants depends on the mass of the original star. These remnants are called white dwarfs, neutron stars, and black holes. Each of these objects represents a different fate for a star. These objects are incredibly dense and have very strong gravitational pulls. Their densities are so extreme that they defy our everyday experiences. White dwarfs are the remnants of low-mass stars like our Sun. After exhausting their nuclear fuel, these stars shed their outer layers and leave behind a hot, dense core. They are about the size of Earth but have a mass similar to the Sun. This means that a white dwarf is incredibly dense, with a teaspoon of its material weighing tons. Neutron stars are the remnants of more massive stars. When these stars explode in a supernova, their cores collapse under gravity to form neutron stars. They're even smaller than white dwarfs but are much denser. A neutron star's density is so high that a sugar cube-sized amount of its material would weigh as much as a mountain. Black holes are the strangest and most mysterious objects in the universe. They represent the ultimate end state for the most massive stars. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. This boundary is known as the event horizon. They are formed when very massive stars collapse at the end of their lives. This collapse compresses the star's core to a point of infinite density, known as a singularity. We can't see black holes directly because no light can escape from them. However, we can infer their presence through their gravitational effects, but we can detect them by their effects on the objects around them. For instance, a black hole can pull in material from a nearby star, creating an accretion disk that emits X-rays. For example, if a black hole is orbiting a star, we can observe the star's motion. The star will appear to wobble due to the gravitational pull of the black hole. This wobble can be detected with precise measurements, allowing astronomers to infer the presence of the black hole. These stellar remnants, whether white dwarfs, neutron stars, or black holes, offer a glimpse into the ultimate fate of stars and the extreme conditions of the universe.